Now we're going to keep going with right triangles, but we're going to look at the triangles that don't have those special angles in there. So now if I want to find the missing sides, I have to use our right triangle trig. Okay, so if we did our special right triangles, we would have the 45 or the 30 or 60 in our right triangles. These triangles are going to have random angles in there, not the nice pretty ones. So what we're going to have to remember is SOHCAHTOA. Okay, and what SOHCAHTOA stands for, and I wrote it like this for a reason. We have three trig functions that we typically use for our right triangle trig, or finding missing sides and angles. All right, the first one starts with an S, and that's sine. Okay, so we say sine, I don't write this, we'll write it over here. Sine equals, and then the OA's and H's stand for opposite, hypotenuse, and adjacent. So then I'm going to say sine equals opposite over hypotenuse. Right? And the C is cosine. Right? And cosine equals adjacent over hypotenuse. And then the T stands for tangent. And tangent is opposite over adjacent. Okay. Then the opposite, adjacent, and hypotenuse, all of that comes from whatever angle you're working with. So over here, I have theta. Theta is just a variable for an angle, right? If this is the angle that I'm working with, I choose my opposite, adjacent, and hypotenuse sides based on that angle. So for example, the side that it doesn't touch, that's our opposite side. All right? The side that it does touch is the adjacent side. And then the side that's across from the right angle is always the hypotenuse. Always. Okay, now it's easy to get this adjacent and hypotenuse messed up because they're technically both adjacent. They both touch that angle. But the hypotenuse has to be across from the right angle every time. So that means the other side has to be your adjacent. Okay, so if I were to label these sides, let's label them A, B, C. Okay, the way that we write our ratios is we use three letters. We use the first three letters for sine, cosine, and tangent. And then you always have sine of something, and the something is your angle. So in this case, we would say sine of theta, right, of this angle, is going to be opposite over hypotenuse. So my opposite side in this case is A, and my hypotenuse is C. So sine of theta equals A over C. Cosine of theta is going to be adjacent over hypotenuse. So my adjacent side here is B, and my hypotenuse is C. And then tangent of theta is opposite over adjacent. So my opposite's A, my adjacent's B. So tangent of theta is A over B. Okay, so what we're going to have to do is set up an equation like one of these three, right? You got to pick which one it is based on the sides you're given. And then you set up an equation, and then we'll solve our equation. Okay, let me get our next page. Way up here. Okay, so for our four examples, right, we have to label our sides or figure out what our sides are in terms of opposite, adjacent, or hypotenuse. And then we're going to use that to pick the correct trig function and write our equation. Okay, so here, if you notice, I got a 35, a 50, a 61, and a 15. None of those are special right triangles. If we had a 45, 30, or 60, we go back to what we did in the last video and you use the ratios. But if I don't, now's when we use our sine, cosine, and tangent. All right, so here I'm working with the 35 degrees, and I'm working with an x and a 12. Okay, you're always going to be given two sides, at least two sides. Okay, and so I'm going to pick which trig function I use based on how these sides relate to that angle. So like the 12, this is my hypotenuse because it's across from the right angle. And then the x is across from the 35, it doesn't touch it. So that's the opposite. Okay, and I'm using SOHCAHTOA Let's see, let me write SOHCAHTOA over here somewhere. We'll write it down here. All right, gotta memorize SOHCAHTOA. So for this one, because I have opposite and hypotenuse, this one's SO. Okay, so the SO is sine. So we can say sine, right, of the angle, so 35, equals opposite over hypotenuse. So opposite x, hypotenuse 12. All right, then we're going to solve. Now for these, you are going to need a calculator. Now when you go to Delta Math, there is a calculator option there for you, or I mean, you can use your phone calculator. If you turn it sideways, then they usually have the sine, cosine, tangent on there for you, or if you have a regular calculator. So here's mine. If you are using one of these, okay, you got to make sure that you're in the correct mode. So I'm working with 35 degrees. Okay, if you look at the top, at least on mine, it says radian right there. That's where it should say degrees. So what you do is you press mode and you scroll down to the third row here and you highlight degree and press enter. So you do have to be in degree mode if you're going to be using a calculator. If not, you're going to get a very funky answer. Okay, so now I'm just going to come back over here. We got to do a little algebra. I want to get x by itself. So to get x by itself, I'm going to multiply both sides by 12. Okay, and in this, I can type in my calculator just like that. All right, so in your calculator, I'm going to press 12, and then 2 above the 7, 8, 9. So above the comma and parentheses, I've got sine, cosine, tangent right there ready to go. So I've got 12 sine 35, enter. And we've got 6.88, blah, 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 blah. So I'm just going to round to 2 decimal places. So we'll say 6.88. So x equals 6.88. All right, now on Delta Math, it's going to tell you where to round. Make sure you round correctly, because if you, like for this one, if I wanted to round to the 10th, this would be 6.9, not 6.8. And if you type it in as 6.8, you'll get it wrong. So make sure you round correctly whenever it tells you to round. Okay, so there's my answer for the first one. Same setup for the second one. I got to pick my sides and then use that to pick the trig function. So here I've got my 50. The x is across from the right angle, so that's my hypotenuse. And the 4 is next to the 50. So that's going to be adjacent. So this one is the All right, so that's cosine. So we say cosine of the angle always goes with the cosine, or the trig function. So I'm going to put cosine of 50. Okay, and this is just like if you see the parentheses here on my calculator, all right, it's sine of 35. The angle is like inside the sine. Okay, so it's not cosine times 50, it's cosine of 50. Okay, and then I've got equals adjacent over hypotenuse. So 4 over x. Okay, now when I go to solve this one, the algebra is a little different, okay, because right now the x that I want is in the denominator, and I don't want it in the denominator. I can't solve for x if it's in the denominator. So what we can do is we can start by multiplying by x, right? Get it out. I moved it. So now I have x times cosine of 50 equals 4. And then I want to get x by itself. Now remember, this is cosine of 50. That's a number. So if I come back to my calculator, I can type in cosine of 50 and get this ugly decimal here. Okay, but I don't want to type that decimal or write that decimal down because I'm rounding too early, right? But the cosine of 50 is a number. So this is the same as if I had x times 5 equals a number. So to get x by itself, I have to divide by that number. So I'm just going to say divide by cosine 50. And now I have something that I can type in my calculator. So I'm going to do 4 divided by cosine 50. And we got 6.22. All right. Didn't realize how close they'd be. Okay, for the third one. Same start. We're going to start by picking our sides. So I don't have the hypotenuse this time because I don't have anything across from that right angle. So now I have to determine opposite and adjacent. So the x is next to the 61. It's touching that 61. So the x is going to be the adjacent. And then the 9 doesn't touch the angle. So that's going to be our opposite. So now I'm working with adjacent and opposite. So that one's going to be TOA. And I'm working with tangent. So we're going to say tan of the angle 61 equals opposite 9 over adjacent x. And this one looks like the number 2 we just did, right, where my x is on the bottom. So the first thing we're going to do is multiply and then divide. So we're going to go to my calculator and do 9 divided by tan 61, and we get x equals 4.99 because it's 8/8, so it rounds up to a 9. All right, and then for the last one, okay, the 21 is my hypotenuse. Okay, the x is next to the 15, so that's going to be adjacent. So this one's using c again. So we've got cosine of my angle equals adjacent x over hypotenuse 21. And this one looks like the first one we did. X is on top, so it's a one-step problem. We're just going to multiply both sides by 21, and I'm going to type that in the calculator. So, oops, we got 21 cosine 15. So we get x equals 20.28. Okay, so make sure you're in degree mode. And then you have two types. It's going to be a one-step where you multiply by the denominator and then you type it in and you're done. Or it's going to be a two-step where you have to move the x over and then divide by the trig function. Right? But we're only going to worry about finding missing sides for right now.